So, you can't. Alright, so this is machine learning, project 3, using the RBN network and MLP network. We're going to go ahead and set off them to run. The RBN is going to take a little bit to condense the data. The NLP is going to run pretty quick here, but we'll go back to the results in a second. Set the RBN off. If it'll listen to me. There we go. We're going to set the NLP off here. So, alright, so NLP runs pretty quickly. The reason it's doing that, we are only going to run, for the purpose of the demonstration, the wine dataset, because that's a classification dataset, and then the wine dataset, which is the regression dataset, and then the car dataset, which is the classification dataset, to show that our network works on a classification dataset as well as a regression dataset, and that we get an S-score and a mean squared error for these two datasets, for both networks that we run. A quick overview of our code. So they both have the same basic structure. For the RBN, you initialize it. You have a basic string class we can call just to print stuff pretty easily. We have a train, and then within that train, this is where we're checking for convergence. Then calling the iteration if it's not converged. So we call the iteration. This goes through the data points for this. We only did 2 data points to make it run quickly. We're going to show that the weights are changing for each iteration of this. So then this train iteration will call your feed forward class or feed forward method, and then also your backprop method, as well as storing some data along the way. So feed forward, straightforward, just feeds the data through, calculates what your output is, and then based on that, you come back up here, it saves some of the data, and then calls backprop, and so then your backprop, you propagate your error back through to calculate new weight matrices. There's this other function here that calculates the max distance between the nodes for the RBF layer to help get your sigma to be used in your calculations. And then we also have this classify method down here that we call to then classify, run the test data and put it into a classification with what we get out of the network and then what it should be for our F-score and regression. MLP pretty much the same way. Initialize your variables. Here you have your training where you call your iterator, your train iterator, and from the iterator you're calling the feed forward, your backprop, and then training your network that way. It's, again, string method to then print out pertinent data along the way, as well as this classify method to then run your test data and then compare the output to the actuals later on in your S-score and regression. So, going here to the terminal, this was your MLP, molecular perceptron, and so score powerful. Let's just scroll the top real quick. Alright, so you see our weights initially start here. Then as we go through, they get updated. So, yeah, your weights here are different from your weights here. So you see that we are updating the matrices with each iteration. And you get your outputs for each one. So that's your car. Then for the wine, yeah, it's a lot bigger weight matricity, but 0.147 at the top here, negative 1,000 here, you come down here, looking at different numbers, they're getting updated, and jumping around a bit, but, yeah. And so we are updating it, and so that shows that our NLP works and updates the weights as needed. So if we go to see if the output on the other one is done. Alright, so the RBN network has finished running now, and we can go back through all of it, or I can just show you this one iteration with k-means. So I'm going to show you the one, because otherwise you're scrolling through all this. We see here that our initial value of this weight matrix is 0.14, 432052. If we scroll down to the next iteration, we have changed to 0.28. So we are updating the weight matrices as needed and training this network on the different data points. Output says a regression, 50, sorry, MSE. So is that later, and then modoids, your weights are changing as well here. And then let me scroll up real quick and show you the car classification. So so initially, it changed from 4 point something e to the negative 3 to 8 point something e to the negative 3. So again, we're updating our weight matrices for the classification one as well. And so here's a quick results output file that we just print for the RBN. So we have F-score for your different condensing methods on your car data set, and then your mean squared error on the wine folds here. And then here, F-score as well on the car folds, and then mean squared error for the wine fold on the MLP as well. So, that's it. Project 3.